Let's start with the power rule. The power rule is used to differentiate functions of the form ax exponent n, where a and n are real numbers and x is a variable. To differentiate this function, we have to multiply the coefficient with n, then we decrease the exponent by 1. Thus, y prime of x is equal to the coefficient a multiplying the exponent n times x exponent n minus 1. So in our first example, we are to differentiate f of x is equal to 3x exponent 4. To differentiate a function using the power rule, then the function must be in the form of ax exponent n. Comparing these two expressions, we see that a is equal to 3 and n is equal to 4. And so the derivative, that's f prime of x, will be given as we multiply the coefficient 3 with the exponent, that's 4. Then we decrease the exponent by 1, so that's 4 minus 1, which is going to give us 12x exponent 3. Example 2. Differentiate f of x given below. To differentiate f of x, we are going to apply the power rule on each term in this expression. Applying the power rule on the first term gives 1/2 multiplying 2, then x exponent 2 minus 1 minus 1/2 multiplying 5, x exponent 5 minus 1 plus minus 3 multiplying 1, because the coefficient here is 1, then x minus 3 minus 1. Thus, we are going to have x exponent 1 minus 5 on 2, x exponent 4 minus 3x exponent minus 4, because minus 3 minus 1 is minus 4. We can simplify further to get x minus 5 on 2, x exponent 4 minus 3 on x exponent 4. With our third example, we have to differentiate f of x, giving us 3 square roots of x plus 5, then the fourth root of x squared plus 2. To differentiate f of x, we apply the power rule. Now we've learned that to apply the power rule, the function should be of the form of y is equal to ax exponent n. And so we have to rewrite these functions to be in the form of ax exponent n. And thus we are going to have f of x is equal to 3x exponent 1/2, because we can write the square root of x as x exponent 1/2, plus 5x squared, then exponents 1/4 plus 2. So now let's simplify f of x further. So that's 3x 1/2 plus 5x. So now here we are going to have 2 multiplying 1 on 4. So that will be 2 on 4 plus 2, which can be simplified as 5x exponent 1/2 plus 2. Thus, we are going to have 8x exponent 1/2 plus 2. Thus, we now have f of x in the form of ax exponent n. And so the derivative of f will be given as 8 multiplying the exponents, that's 1/2, then x, we now subtract 1 from the exponents. Now when we differentiate a constant, we are going to get 0. 4x exponents minus 1/2, and which can be rewritten as 4 on x exponent 1/2, and that's equal to 4 on the square root of x. So that's the derivative of f of x. The product rule. The product rule is used to differentiate the product of two functions. So given f of x is equal to u of x times v of x, then the derivative of f of x is giving us u prime of x times v of x plus u of x times v prime of x. So we just have to identify u and v. Then we differentiate each of these functions, then we substitute into this expression. Example 1 on the product rule. Differentiate f of x giving us x squared sine of x. In this example, we have an algebraic function, that's x squared, multiplying a trig function, that's sine of x. And so we have the product of two functions in this case, and we're being asked to differentiate this function. So we just have to identify u of x and v of x. So now let's choose u of x to be the algebraic function, that's x squared. Then we now take v of x as sine of x. Now what do we need again? We just have to differentiate u and v. So to differentiate u of x, we use the power rule because u has the form of ax exponent n. And so we are going to have 2x exponent 1, which is 2x. Then we differentiate v of x. Differentiating sine of x gives cosine of x. And thus f prime of x will be giving us u prime of x times v of x plus u of x times v prime of x. And so we are going to have u prime of x is giving us 2x, and v of x is giving us sine of x, plus u of x, which is giving us x squared, times u prime of x, which is giving us cosine of x. You can factor out x in these two terms, so that's x out 2 sine of x plus x cosine of x. So this is the derivative of f of x. Our next example on the product rule is to differentiate the function given below. In this case, we have an algebraic function multiplying an algebraic function. So we have to identify our u of x and our v of x. So u of x can be chosen to be 3x plus 5, and v of x will now be equal to 2x squared minus 3. Now let's differentiate u of x. Each of these terms has the form of ax exponent n. So we are going to apply the power rule to differentiate u of x. So we are going to have 3 multiplying the exponent, which is 1, then x 1 minus 1, plus 5 is a constant, so it will go to 0. So that's u prime of x is giving us 3x exponent 0, and that's equal to 3. Now what about v prime of x? So v prime of x also has the form of ax exponent n. So we are going to have 4x minus 0, because 3 will go to 0 when we differentiate it, so that will be 4x. So now we now have all the terms that we need, and so f prime of x will be giving us u times v prime. So u multiplying v prime, so that's going to be 3x plus 5, all multiplying v prime, which is 4x, then plus v, which is 2x squared minus 3, multiplying u prime, which is 3. So now simplifying this expression gives 12x squared plus 20x plus 6x squared minus 9. We can now add 12x squared and 6x squared. So that's going to give us 18x squared plus 20x minus 9. So that's the derivative of f of x. Let's consider our last example on the product rule. So here we have to differentiate f of x, giving us x squared ex plus cosine of x sine of x. So let's call the first term say y, and let's call the second term say z. So we are going to apply the product rule on the first term y, and we apply the product rule on the second term, which is z. Y is equal to x squared ex. Now let's apply the product rule on this function. So we choose u of x to be equal to x squared and v of x to be equal to ex. Now let's differentiate. So when we differentiate u of x, we are going to have 2x, and when we differentiate v of x, we are going to have ex. Since the coefficient on this term is 1, it will just be 1 times ex. So then the derivative y prime will be giving us u times v prime. So that will be x squared ex plus v times u prime. That's 2x ex. I apply the same idea on the z term. So that's for the second term, z is equal to cosine of x sine of x. We choose our u to be cosine of x and v to be sine of x. So differentiating cosine of x is going to give us minus sine of x, and differentiating v of x is going to give us cosine of x. And so z prime will be giving us u times v prime of x. Thus cosine of x multiplying cosine of x plus u prime times v of x. So that will be minus sine of x multiplying sine of x. Cosine squared of x minus sine squared of x. So we said that f of x is equal to y plus z, which implies that f prime of x will now be equal to y prime plus z prime by the sum and the differential rule of differentiation. And from above, we have y prime of x giving us x squared ex plus 2x ex, then plus z prime of x, which is giving us cosine squared minus sine squared of x. So we can factor out ex and x from the first two terms. So that will be x out, ex out, then x plus 2, then plus cosine squared of x minus sine squared of x. The quotient rule. The quotient rule is used to differentiate functions of the form u of x divided by v of x. So in this case, we expect v of x not to be 0, because if v of x is 0, then the function f of x will be undefined. Then the derivative of f of x is giving us v multiplying u prime of x minus u multiplying v prime of x, all divided by v of x squared. So here u of x is the numerator and v of x is the denominator. With our first example, we have to differentiate y of x, giving us x squared plus x divided by x cubed plus 1. So here we have to identify our u of x and v of x. So u of x is the numerator, so that will be x squared plus 6, and v of x is the denominator, so that's going to be x cubed plus 1. When we differentiate u of x, we are going to have u prime of x to be equal to 2x. Then when we differentiate v of x, we are going to have 3x squared. Thus we apply the power rule to differentiate these functions. Then we have to substitute it into the formula. So we have f prime of x giving us v u prime minus u v prime divided by v squared. And so we are going to have v of x, that's x cubed plus 1, u of x, 2x, that's 2x multiplying x cubed plus 1 minus u of x, which is x squared plus 6 multiplying v prime of x, which is 3x squared, all divided by v squared, that's x cubed plus 1 all squared. Now we have to simplify this expression. So we are going to have 2x multiplying x cubed. That will give us 2x exponent 4. Then 2x multiplying 1 will give us 2x. Then minus into brackets. So we have x squared multiplying 3x squared. That's going to give us 3x exponent 4 plus 6 multiplying 3x squared. That's going to give us 18x squared, all divided by x cubed plus 1 all squared. So we are going to have 2x exponent 4 plus 2x. So we now distribute the minus. So that will give us minus 3x4 minus 18x squared divided by x cubed plus 1 all squared. Our next step is to add like terms. So we have 2x4 minus 3x4. So that's going to give us minus x4. Then plus 2x minus 18x squared divided by x3 plus 1 all squared. And so this is our derivative for f of x. With our last example, we have to differentiate w of x, giving us e minus 3x plus x divided by x squared plus 1. So in this example, so we apply the quotient rule since we have a rational function. So we have to identify u of x, and u of x is the numerator. That's e minus 3x plus x. And v of x is the denominator. That's going to be x squared plus 1. Now we differentiate both functions. So differentiating u of x, that's u prime of x is going to be, so we have minus 3 here. So that's minus 3 will come down. Then e minus 3x plus 1. When we differentiate x, we are going to have 1. Then v prime of x will be equal to 2x plus 0. That's when you differentiate 1, you are going to get 0. Now we now substitute it into the quotient rule formula. That's f prime of x is giving us v u prime. And what's v? X squared plus 1. And u prime is giving us minus 3e minus 3x plus 1 minus uv prime. So u is giving us e minus 3x plus x multiplying 2x. So we are going to expand. So this will multiply that, this will multiply that, and here also 1 will multiply these guys. So that's, we are going to have minus 3x squared e minus 3x plus x squared minus 3e minus 3x plus 1. Then for the second term also, we are going to have minus 2x e minus 3x minus 2x squared, all divided by x squared plus 1 all squared. Thus we have x squared minus 2x squared, so that's going to give us minus x squared, and we have the constant 1. For the rest of the terms in the numerator, we can just factor out e minus 3x, so that's going to be e minus 3x out minus 3x squared minus 3 minus 2x, all divided by x squared plus 1 all squared. Thus, our derivative of w of x is given below. Thank you for watching. See you in the next video.